Hi, Bobby.
Hi, Aniruddhan. Now what we will do?
So we have looked at all kinds of diodes, no?
Yeah.
Regular diode, Zener diode, forward bias, reverse biased, with only capacitors, with resistors, sinusoid, DC. We have looked at a whole bunch
I
of
think
things,
we
no?
are quite comfortable with that. Now we have to move on.
Correct.
So diode was one junction, PN.
Correct.
Can I have more junctions?
Okay. More junctions. Maybe we'll start taking two. So maybe two junctions. We'll take two diodes and put them together. Shall we start with that?
We'll try.
Right. So maybe we'll do that. What I will do. Well, I'll take two diodes like this. Why not? You can connect them like this. So I'll get a. So this was P, this was N. This is P, this was N. So I have two junctions. Exactly what you asked for.
Okay, but these junctions have no interaction.
Correct. Correct. That is right.
They are independent. They are just neighbors.
Correct. You want to put them in the same house.
Yeah.
And see what happens, the fights that will happen.
Yes.
Okay. Well, yeah, actually if you look at this, if I just connect these circuits together, whatever I connect, no current will flow.
Yeah.
One will be forward biased, one will be reverse biased. For any voltage, nothing will happen.
Correct.
Right, actually. So maybe we'll keep this aside and move it to one corner.
Yeah.
So
this is not helping us.
Not very helpful. Right. So maybe what I need to do, instead of connecting two junctions by a wire, we will just fuse. I have two P types. I can just make it one long P type. Right? So then let's try that. So I'll just do this.
So you are in the fabrication step itself, it's a
correct
different process.
It's a different process. So I'll make it like this. So I'm going to combine these two, I'll just put one P there.
Okay.
I'll make it like this and see what happens. But this P, is I earlier had a connection here.
Yeah.
So shall I pull out one wire like this?
Oh.
Something like this. So I could do this.
Oh. So this has three terminals now.
This has three terminals now. See, earlier you asked me to take two junctions.
That is true.
I had 1, 2 and 3. So now I have to retain those. I don't want to lose that. So I'll some 1, 2 and 3, something like that. Right?
Now, how will this behave? I have no idea.
Okay. So in fact, this is probably not very useful because it will give us some behavior, but most likely, like you said, they were neighbors here.
Correct.
Now they have only come to the gate.
Yeah.
Right?
Yeah.
They have not become part of the same house.
Correct.
So to do that, you need to do one more step. Right? So we came from here to here. Right? So we came from here to here. Now we'll do one more step.
What is that?
What we'll do, we will make this P very thin.
Oh.
Shall we do that and see what happens? So now that is our next step. So we'll fabricate it.
So the one in the middle is very thin.
Very thin. Right? So then I will get something like this. I will exaggerate it like this. Now I don't have space anymore. I'll draw it down here. So this is P and this is N and this is N.
Okay.
Something like this. I'll move it up.
That is better.
I'll move it up here. I'll do it like this so that I can still have this connection,
Yeah.
So 1, 2 and 3. So now I have made the P thinner and thinner and thinner. Right? In fact, if you make it very thin, actually what will happen, even if I take a wire like this, most of the current I think will try to go from
1 to 3.
1 to 3. Right? I think very little current will try to even flow through 2 if I make it very thin.
Whether this has got any symbol or name?
Correct. Now we need to look. Now we can't use these two diodes anymore.
Correct.
So this will now have a new symbol. See, in the diode, you only had one anode, one cathode.
Correct.
and as you pointed out, the arrow, the diode is pointed towards the direction of current flow. So we need to take into account all of this. First of all, it is no longer a diode. We need a new name.
Yeah.
What shall we call it? Shall we call it transistor?
Transistor.
Yes. Huh?
Any logic for that?
I don't know.
Somebody
You know,
named like
somebody
that.
named it like that. So some names I have heard is it's a trans resistor became a transistor, right? To do that, we need to understand how it works,
Correct,
no?
correct,
So I have heard names like that, but we will call it a transistor,
Okay, okay.
right?
So 3-terminal device.
3-terminal device.
What kind of symbol?
So the symbol needs to have 3 terminals, and like you said, it also needs to show the current direction, right?
Whether this 1, 2, 3, those regions have any name?
Okay. So this
There you said cathode.
And anode. So now we need to name these as well, no? What we will do, so they do have names, so shall we name them? So shall we say, shall we call this the collector?
Okay.
Because it collects current, right? Something like that, or it collects charge carriers,
Okay.
or right? Not current. So we'll call this the base, and we will call 3 the emitter,
Emitter.
because it emits the charge carriers.
Okay. Okay.
We'll call it like this. And most likely, because we have N no here, it must be emitting electrons. Most likely, it must be emitting electrons. The electrons must be going via the base into the collector. We said we don't want any current coming out of the base, right? Actually, if the students pick up a semiconductor devices textbook, just like the diode, there is a lot of device physics details about how to build the device, how to analyze in terms of electric fields, charge carriers, things like that. But we will
use the symbol and equations.
We'll use the symbol. So we have put them in the same house. They are fighting. We want to figure out. We don't want to figure out what they are fighting about. We just want to make sure they are fighting.
Okay.
Right?
As long as we have an equation to represent their fighting characteristic, that's enough.
Correct. That's right. Okay. So this emitter is going to emit electrons. Nothing or very little comes out at the base. Most of it goes to the collector. But now, electrons are negatively charged carriers.
Correct.
So we can't show the arrow showing the direction of electrons. So we need to show the opposite way. So shall we draw it, the symbol? So the symbol for a BJT is like this.
BJT.
Yes. So the symbol for the transistor, but this transistor is called a BJT, or we have 2 junctions, no? So it's a bipolar junction transistor, because you have 2 junctions.
Okay.
This is called a bipolar junction transistor. And we have 3 terminals.
So we'll mark the emitter.
Correct. So we chose this, we'll call this the collector.
Collector.
This is the emitter. So the reason I drew it like this, we saw that the current, electrons go from emitter. So the positive current has to go out of the emitter. So that's why I have shown the arrow like this. And this is the base.
I cannot show the arrow in collector.
You cannot show the arrow in the collector. That is right. So we'll also.
I can do this with instead of P as the base. Can be N
you
also.
Can do the N also. So you can take 2 diodes. Of course. So that will become like this. So suppose I were to take like this, no. So you can have P, N, and P.
Yeah.
Right. So that is also okay. So then this would.
That symbol of that will also be same.
Symbol also of that will also, well, symbol has to change, no, because now the current direction
has changed.
Correct. So what did we call these 1, 2, and 3? No.
Yeah.
So let's follow the same 1, 2, and 3. So 1, 2, and 3. Same way, collector, base, emitter, right? But now emitter is emitting holes, not p-type charge carriers.
Yeah.
Right? We saw that they were called holes. So
current direction
seems opposite, no? So we need to change the symbol. We'll use something very similar. So this portion of the symbol stays the same, except I'm going to flip it. Well, so I can draw it like this. So base, collector, and now this is the emitter, right?
Yeah.
I can show like this.
Okay. So that's the only difference.
This is the only difference. And people also draw it upside down. They prefer current, but this is perfectly fine. Or you can also draw it like this. But you can draw it like this, for example. So emitter, I'll call it E.
Yeah.
Collector and base.
Yeah.
It doesn't change you're just drawing it in a different way.
Yeah.
Right? Just like you can draw the diode like this, it doesn't matter. Right? You can draw it like this. It's the way to draw the circuit.
So always this direction is between emitter and base.
Emitter and base. Correct.
Now, which direction is decided by its NP or PN?
Correct. That's right. So then now we need to be more careful, no? So what I will do, I will call this an NPN BJT.
Okay.
Or an NPN Bipolar Junction Transistor. And this one will then be a PNP transistor. In fact, people just call it PNP transistor or an NPN transistor.
Yeah.
Right?
Yeah. Okay. It has got some shape and symbol that I got it.
Correct.
But
And it has 3 terminals.
3 terminals. Now we need to know how it behaves.
How it behaves. But before we know that, we saw that it is almost little bit like putting 2 diodes together, no? And the minute you do that, we saw that one of them is forward biased, one of them is reverse biased. So most likely something like that is going to happen here, right? So maybe we'll look at that now first.
Okay.
So I'll show let's take an NPN. So we'll see. So you have 2 junctions. So now collector is going to be C. I'll just call it C. Base is B and emitter is E. It's just easier to just mark the letters.
Correct.
Okay, and this is N, P and N. And we said current is flowing like this, no?
Yeah.
Current is flowing like this. If the current is flowing out of the emitter, that junction has to be forward biased. So this is that junction has to be forward biased. So I'll just say forward biased. The other junction has to be reverse biased. Collector base junction. Because they look like 2 back-to-back junctions, no?
Correct.
So we will mark it like that. So this junction is reverse biased, right?
How we will reverse bias this? Externally we will.
Externally you will have to apply the voltage.
Okay.
Correct. So externally you will have to apply voltages to collector base emitter such that the collector base junction is reverse biased, the base emitter junction is forward biased. So this is forward bias.
Okay.
So if you do that, this is the normal way of using the device.
Most of the
time you will be using it like this.